Now let's start with the first chapter, that is moment of inertia. So here it is the definition of moment of inertia. Last time we have discussed about the topic what is the mean by moment of inertia, how it is related to our past subject, that is applied mechanics. Recently we have studied about the force, center of gravity, isn't it? Centroid. So these are the topics that we have already studied in applied mechanics. So these are the topics from applied mechanics are related to this moment of inertia chapter. That how it is related, what is the updatement in that. That last lecture we have discussed about it. Now let us start with the chapter moment of inertia itself. Now it is from third semester civil engineering diploma and mechanical engineering diploma. So this is the definition of moment of inertia. So moment of inertia is basically, it is a, you can define it as a second moment of area. Moment of inertia, in short, you can define it as a second moment of area about certain axis. That is a moment of inertia. You know better about what is a moment. MOMENT. What is moment? So in applied mechanics, we have studied about the moment of a force, isn't it? Moment of a force. It is a product of force multiplied by perpendicular distance from that force to the point where you are finding the moment of that force. That is a moment of force that we have studied in applied mechanics. Now here it is, moment of inertia is the second moment of area. Second moment means what? The first moment of area is area multiplied by distance. Similar to that, that is force multiplied by distance. Similarly here, area multiplied by distance is the first moment of inertia. If you want to take second moment of the same area is same, but you have to take second time it's a moment. Then once again you have to multiply it by distance. So the first moment is area multiplied by distance, and second moment is area multiplied by distance, and once more another same distance. So area multiplied by distance means area multiplied by distance square it is. So here it is the definition you can see here, isn't it? It is the second moment of area, which is equal to product of area of the body and the square of the distance of the of its centroid from the axis. It's called as the moment of inertia. Now, what is exactly you want to say about the moment of inertia? Here it is, you can see. See, if you want to define what is moment of inertia in another way, you can see here. Suppose someone area is taken, right? Here it is, someone area we have taken. Now this area, you can divide it into small, let us for example, 3 small elemental areas that we have taken. So this total area, now I will show it by colors. So this is the total area. Closed, that's why. Let's take another. Okay, this is the area. This area, let us show it by some color. Now this area, suppose have 3 elemental parts. Let us have some 3 elemental parts. First one, second one, and third. So this will be, let us call as a DA1. This is, let us call as a DA2. This is called as a DA3. Now the whole area of the body is, suppose area of the that lamina is equal to capital A, for example. So this is the area that you have taken, for which you have to find out the moment of inertia. Now the moment of inertia has the notation I, isn't it? So I is the notation used for moment of inertia. And along with that I, that is the notation of mi, certain axis is mentioned. What is that axis? For example, this is the IXX. Means what? The moment of inertia of this lamina about the axis XX is called as the I-axis. In short, I represent mi, that is moment of inertia, and x-axis is the about which you are taking the moment, about which you are taking the moment twice, isn't it? So this is the area. Let us divide it by, for example, small three elemental parts. There are infinity number of elemental parts. We have taken, for example, dA1 is the first small element, second dA2, dA3. Okay. Now, where it is the that axis, that this axis you are mentioning here, IXX, where it is that axis? Let us suppose here it is the axis XX. Okay. So this axis XX, I will rub this part. Area, the total area is A. I will mention somewhere else. So here it is. The total area is equal to area A. Now, this total area has three small elemental parts, 1, 2, 3, and you have to find the moment of inertia I, as earlier mentioned. About which axis you are finding now? About x-axis. Means what? The moment of inertia of this lamina or area, you have to calculate moment of inertia of this area about this x-axis. So you are referring this x-axis over here. That is the moment of inertia about x-axis. Okay. So moment of inertia about x-axis now, how it is taken as earlier? It is a second movement. It is a second movement of area. So this whole area is the summation of all such elemental parts. This area has infinite number of small elemental parts. For example, we have taken first, second, third. Now, according to definition, mi is the area multiplied by square of the distance. Now, let us have this distance of dA1 as y1, of this area y2, of this area y3. It is a perpendicular distance. I have shown it in my perpendicular distance from this. So it is a second moment of, I will show once again that distances. So here it is the first distance, here it is the second distance, here it is the third distance. So let us call it as a y1, y2, and y3. Is it? So the total area divided into small elemental infinity parts. Out of that, we have taken first, second, third, for example. So the first area has a distance y1, second area has y2, third area has y3. Now, according to definition of MI, what is that? Area multiplied by distance square, isn't it? So area multiplied by distance square means the first one, that is dA1 into y1 square, is it? Plus, now second area, dA2 into y2 square, plus third area, dA3 into y3 square, isn't it? Someone waiting for that. Yeah, we have to admit those guys here. Let us admit them. Okay, they are admitted now. Now, so moment of inertia of this area is area multiplied by distance square. So this area we have divided into, for example, three parts. There are infinity parts. For calculation purpose, we have taken shown 1, 2, 3. So dA1, according to definition, area multiplied by distance square. So it area multiplied by distance square y1 square. Similarly, for second, dA2 y2 square. Similarly, for third, dA3 y3 square. So this summation So this part, summation of all parts dA1, dA3 continues up to infinity. Then it gives the moment of inertia about x-axis. So moment of inertia of this lamina about x-axis is the summation of all elemental parts जो ले रहे हैं हम लोग dA1, 2, dA3, dA3, etc. So summation of movement of all small elemental parts taken about the x-axis. So dA1 into y1 square. Why it is square? Because we have to take second movement. First movement dA into y. Second movement dA into y into y. That is y square. So dA1, y1 square, etc., etc. If this summation continues up to infinity, then if you add all those things, then it will give ix. So this is the finally we can define it as I is equal to area multiplied by distance square, and summation will be shown like this. So summation of area into distance square. So here it is dA, all parts of dA, n, distance is yn square. So this n tends to 0 to infinity. So this n 1, 2, 3, 4, 5, 6 infinity, 1, 2, 3, 4, 5, 6 infinity. Then it gives the summation of all elemental parts. Okay. So that is the, in short, that is the definition of moment of inertia. So once again, if you go for moment of inertia, so here it is the moment of inertia. You can shortly show like this. Suppose taken someone rectangle. If you take someone rectangle over here, I will take rectangle. Isn't it? Now this rectangle, and it has two axes, x axis. Another axis is a y axis. So this moment rectangle has area equal to A, isn't it? Then it's a moment of inertia about x-axis. That is the area of this rectangle has been taken movement for about x-axis twice. And that formula, if you derive, it comes to be BD cubed by 12. Isn't it? What is B? B is the width of this rectangle. What is D? This is the depth of rectangle. So B into D square, D cube. So here it is the distance D, and here it is the distance B. So BD cube by 12. This is the first formula of rectangle that you can use as a I-axis. Suppose you take another formula for y axis, then it is DB cube by 12. So this is a second formula of y. First formula x, BD cube by 12. So these are the standard shapes: rectangle, circle, semicircle, quarter circle, triangle. So these are the five standard shapes that you have to remember the formula for mi about x and y axis both for each of these figures. This is, here it is I have shown about the rectangle x axis and y axis. Suppose you take another shape, that is if you take suppose circle. Suppose you have taken someone circle here. Yeah. So this circle, here it is the circle. Now if you take its x axis, x axis. Suppose this is the x axis. Here it is the y axis of that circle. The area of that circle is A. Its diameter, suppose taken as a D. Okay. Then Ixx and Iyy of both of them, about both axes for a circle, it comes to be pi by 64 d raised to 4. So this is another shape that you have taken about rectangle, sorry, circle. So the for circle, if you take moment of inertia about x-axis and about y-axis, being it is a circle, so it is same pi by 64 d raised to 4 about both x-axis and y-axis. Suppose you take another third one. Okay. Suppose you take another third one, that is a semicircle, suppose. Or you can take as a triangle another one, no problem. That is a triangle. Is it? Suppose you take triangle, then here it is the triangle. If you draw its x axis somewhere here, x axis somewhere here, y axis. This is the y axis, x axis. Here it is the center. You know the center of that triangle, isn't it? Where it is? Suppose this height is h, then this distance is h by 3. Suppose this width at base is b, then this distance is b by 3. You know better. That is from your academic standpoint. So this moment of inertia about this triangle about x axis, that is equal to ix is equal to bh cubed by 36. Isn't it? So many formulas there about y-axis for semicircle or quarter circle. So we will formulate or we will prepare a chart for x and y-axis for these standard cases, that is rectangle, circle, semicircle, etc. Then another shapes are there: hollow rectangle, hollow circular section. Another cases are there. So what is moment of inertia? Finally, the moment of inertia is the second moment taken of an area about any particular axis. Then it is called as a moment of inertia about that particular axis. Means suppose you are referring Ix means area A, it's a moment taken twice about x-axis. Ix means moment of inertia about x-axis means moment taken twice about the axis x. What about Iyy? You have taken moment about y-axis. That is Iyy. Means the distance measured up to y-axis. So then Iyy. So these are the standard cases that just earlier we have mentioned over here. Now let's go for another formulas and another theorems are there, that is perpendicular axis theorem, parallel axis theorem. Another definition is there, radius of gyration. So these are the initial theoretical part of your subject, your topic, moment of inertia. So the first one, moment of inertia, finally we can say it as a second moment of area, that is a moment of inertia. एरिया का दो बार लिया गया मोमेंट इज अ मोमेंट ऑफ इनर्शिया. पहली बार लिया हुआ मोमेंट and area multiplied by distance. दूसरी second time twice if you have to take that area multiplied by distance multiplied by distance, so area into distance. Then there are certain formulas for that. Then the next one is what is here it is the another definition you can go for that. Radius of parallel axis theorem, then radius of gyration. Here it is the parallax system, which is a very important because moment of inertia you can call it as a near about a very important hard chapter of any structural analysis, because moment of inertia itself defines which one is the weaker plane of the body. Suppose you have take Ix and Iyy, means Ix suppose its value is 10,000 and Iyy suppose its value is 8,000. So 8,000 is weak than 10,000. Means the y axis is weaker than x axis. So failure definitely it will start from weaker section. So where the failure starts, that will be defined by moment of inertia. So moment of inertia itself is a very important chapter. So to calculate moment of inertia throughout your that is third year, then the engineering for second, third year, etc. There are many structural subjects, SOM 1, SOM 2, design, etc. So for all these subjects, you require the parallel axis theorem to calculate moment of inertia of other diagrams. Other diagram means already we have mentioned 5 standard diagrams, that is rectangle, circle, semicircle, quarter circle, and triangle. Then another subpart, that is hollow rectangle, hollow circular, etc. These are the standard shapes for which you can derive certain formulas, and according to that formula, you can get the value of moment of inertia directly. But certain another values, basically, for example, uh, let us see here. I will show another someone. basically T section for it. Is it? This is the T section. Now for this T section, there is no standard formula for Ix and Iyy. Now you have to calculate the moment of inertia of this T section about x axis and about y axis. Means you have to calculate Ix, you have to calculate Iyy, and there is no standard. There's a standard means already we have derived in short form. That is the rectangle. For rectangle, what is Ix? B dq by 12. So it is handy. You can use BDQ battle regularly to calculate moment of inertia of rectangle about x axis. But in the case of that T section, I section, etc., there are no so handy formulas available with you that you can directly call as calculate I axis and Y. You have to calculate I axis and Y by using this formula, that is parallel axis theorem, isn't it? So by using this parallel axis theorem, you can calculate I axis, Iyy for any other shapes T, I, channel. So to calculate those, you require parallel axis theorem. Then next, let's go for another one. See, here it is another one, that is the radius of gyration, which is another important definition from your examination paper. You can see many times it is repeated or define radius of gyration because its importance is very high. So what is radius of gyration? So the radius of gyration of a given area, you can see about any axis, is that distance from the given axis at which the entire area is assumed to be concentrated, isn't it? Without changing the MI about the given axis. What is that? We can explain it later on. I will just concluding about the part moment of inertia. Is it? So these are the parallel axis theorem, perpendicular axis theorem, radius of gyration. These are the definition and theorems we have to see next time. But what we have studied today, that is the definition of moment of inertia and definition along with its explanation, that is where the area is taken, where is the axis, which distance you are taking, etc. etc. Then the moment of inertia of the standard shapes, BD cube by 12, that is the I axis for rectangle, pi by 64 d raised to 4, that is the I axis, and Iyy for circular section. Then these are the standard cases. Then we have to go for, जैसे कि यहाँ पे देखिए, we have to calculate moment of inertia of a channel. Yeah? So for this channel, you have to calculate moment of inertia. This is your problem from your examination. Calculate moment of inertia about a centroidal vertical and horizontal axis. Horizontal and vertical axis means what? That is nothing but जैसे मैंने अभी बताया था आपको. It's a moment of inertia about this is the horizontal axis, x axis, and here it is the y-axis. Here it is the center of that. So we have to calculate I-axis and Iyy. That is, here it is the x-axis, and here it is the y-axis. For this I-axis and Yy, you have to calculate a moment of inertia of this given shape, that is channel. So similar another problems are there. We will conclude it next time. Which type of the problems are there? There are basically three types of problems. Moment of inertia of the standard cases. Moment of inertia of such gives standard sections now. Sections, channel section, I section, angle section, T section. These are the four standard sections. That is, we are going to use these sections as the still sections while you are designing third year subjects. Then another combined diagrams, that is rectangle is placed over the circle, or some semicircle is cut down from a rectangle. You know better about the centroid chapter you have studied last time. जैसे मैं बताऊं अभी यहाँ पे, suppose last time आपको याद होगा, calculate the centroid of this diagram. So this one is the cut down portion of a rectangle. So this is the remaining part. For this remaining part, you have calculated centroid of that part. Similarly, such combined diagrams are there, either cut down or some added diagrams are there, for which you have to calculate moment of inertia. Okay. So next time we will continue with the definition, that is concluding the definition, and then parallax theorem, then moment radius of gyration. Then we will go with these problems. So you go on watching with our lectures, because these initial lectures already we have recorded in our YouTube through our channel. Or Sir's Ranker channel is there. You subscribe it, so you will get the initial certain chapters free of cost. That is, these are the certain demo lectures we are conducting. As the regular batches with paid students are there, then I will stop my sharing my lectures. You have to join our classes in that case. So initially, certain 5, 6 lectures are free to everybody. So I'm sharing it with you through YouTube channel. So share my channel, you will get certain initial lectures free of cost. Okay, thank you.